Assalamualaikum to Dr. Dilla and Dr. Nizam. We are from Group 5. We would like to present about the efficiency of eggshell as a low-cost adsorbent for removal of cadmium, kinetic and isotope studies. Now, I would like to introduce my group member, which is Muhammad Zarif Hazim bin Kamaruzaman, Muhammad Tariq Baik bin Saiful Anwar, Izlan bin Johari, Amirul Faris bin Muhammad Salam. Assalamualaikum, my name is Tariq and I would like to start the presentation with the abstract part. In addition to other calcium carbonate sources, eggshell effectively eliminates heavy metal from aqueous solutions. The absorption capacity of eggshell depends on their physical-chemical characteristics and the impact of experimental conditions. However, in the majority of reports, not all the reaction parameters related to the heavy metal absorption process are available, and the absorption mechanism is not systematically studied. The utilization of eggshell waste is discussed in this contribution to construct an average performance trend of the experimental parameters on cadmium ion. Absorption from an aqueous solution. The use of several physical-chemical methods, which is scanning electron microscopy, Fourier transform infrared spectroscopy, thermogravimetric analysis, Bernal and Taylor, and X-ray diffraction, are used to characterize the physical-chemical properties of eggshell. The physical-chemical properties of eggshell and the effectiveness of adsorption is investigated as a function of contact time, pH, concentration, and adsorbent dosage. The high specific area of the eggshell utilized in the study is largely responsible for the greatest adsorbent capacity, 217.4 mg, attained in 10 minutes at an initial pH of 5 with an adsorbent dosage of 0.8 gram. The isotope model of Lamoille, which is defined by the chemical adsorption of a homogeneous monolayer of cadmium ion on the surface of eggshell adsorbent, is used to describe the absorption kinetics, which is in excellent agreement with the actual data. In the presence of nitric acid, the desorption of cadmium ion is effective. The study findings support the use of eggshell as a material that is both efficient and affordable for removing cadmium. The result shows that the capacity adsorption of cadmium ion is higher than the majority of the adsorbents such as grapefruit peel and banana peel. Because it has so many advantages for people, the environment, and the entire globe, there are still many ways to improve the qualities of this material to produce products that are excellent enough to use in daily life.
Thanks to Tariq Baik. Assalamualaikum warahmatullahi wabarakatuh. My name is Islam Benjari and I would like to continue my presentation with introduction of efficiency of eggshell as a low-cost absorbent for removal of cadmium. So firstly, cadmium is one of metal that is among the most hazardous and offers a substantial threat to human health, since it may lead to serious illness and a variety of ailments when consumed in excess. The primary source of cadmium wastewater that has been released from many industrial areas, including stabilizer, alloys, paint, pigments, CDNE, batteries, and textile printing industry. Toxic metal pollution of the environment is a common problem that frequently includes enormous amount of wastewater. They were slow to decompose, unlike other contaminants, and can build up across the entire food chain, potentially endangering human health and causing ecological destruction. Next is eggshell have the ability to sequester metal, making them environmentally significant for lowering the concentration of heavy metal. The usage of eggshell was particularly important since it was a common food industry waste. It was inexpensive and environmentally friendly because it is readily available and free of any harmful or dangerous component. Several techniques include membrane separation, coagulation, adsorption, ultrafiltration, reverse osmosis, and solvent extraction have been employed to remove cadmium. These techniques are quite costly and only work when there are significant amount of metal in an aqueous solution. The adsorption technique out of all of them is a low-cost conventional treatment method. The main criteria for choosing a good absorbent are having a high absorption capacity, a wide local supply, a reasonable price, and being ecological acceptable. Thank you. That's all from me. Next, I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Faris bin Muhammad Solang. I will be explaining on the methodology on the project. The methodology has 4 sections, which are preparation of eggshells, determining the pH 0.0 charge, the characterization of the eggshells, and the absorption experiment. For preparation of the eggshells are collected from household kitchen wastes. They are washed with deionized water multiple times and is dried at 70 degrees Celsius for 12 hours. After that, they are crushed and sieved in order to obtain powder with the size of 200 to 1000 micrometer. Lastly, and they are stored in sterilized containers for later use. Next is to determine the pH 0.0 charge. The pH 0.0 charge is determined by adding 0.05 grams of adsorbent in sodium chloride solution of 0.1 mole per liter. The suspension pH value is adjusted with 0.1 mole hydrochloric acid, and they are measured after stirring at 150 rpm for 24 hours. Next, for the characterization of the eggshells, the morphology of the eggshells are observed with scanning electron microscopy or SEM. The crystalline species, on the other hand, is recorded with the XRD analysis. The thermostability is then measured with using thermogravimetric analysis, and lastly, all the functional groups on the surface of the eggshells are identified using FTIR. For the adsorption experiment, for cadmium adsorption, it is carried out under 25 degrees Celsius under magnetic stirring at 250 rpms. Various mass of eggshells are mixed with 25 ml of cadmium solution at different concentration, and lastly 0.1 mole of hydrochloric acid is added to keep the pH value in between 2.5 to 7 pH in order to avoid from the precipitation of the cadmium ions. That is all from me. Thank you.
Assalamualaikum. My name is Muhammad Hussein bin Kamar Zaman, and I'm going to present about the result and discussion from the study. To obtain a good absorption of the eggshell, kinetic modeling reveals the phase that limits the process and provides details on absorption mechanisms. 3 kinetic models were used, which is pseudo first order, pseudo second order, and intraparticle diffusion to explore the absorption processes of cadmium ions on the eggshell. From the 3 kinetic models, the pseudo second order model is the best fit that describes the experimental absorption data with a higher correlation coefficient, which is R2 equals to 1, compared to the pseudo first order R2 equals to 0.93, and the theoretical experimental values of QE, which is 11.87 mg per gram, close to the experimental value, which is 11.86 mg per gram, determined from the graph A and B. The results indicate that the pseudo second order absorption mechanism, which is based on the idea that chemical absorption, which involves the interaction between adsorbent and adsorbate, which is metal ion, that controls the absorption rate and predominates. Thus, chemisorption is crucial to cadmium-2 absorption by ion exchange on the eggshell. From the graph C, the curve of Qt versus T to the power of 0.5 is nonlinear and does not pass through the origin. It can therefore be concluded that the intraparticle diffusion can be divided into 2 distinct linear regions. The first linear corresponds to the transfer of the metal ion from the solution to the outer surface of the eggshell. The high initial rate of cadmium removal is due to the strong electrostatic attraction and active adsorbent sites, with cadmium-2 diffusing into the pores of the absorbent. This step represents intraparticle diffusion or diffusion into the pores. The second step, it indicates that the ion absorption process has gradually reached the final equilibrium between the solution and the absorbent. There are comparisons on the literature on the absorption capacities of eggshell and other absorbents for the removal of cadmium 2 plus. Despite the fact that comparison of the capacity removal of various adsorbents is difficult due to the variety of experimental conditions, this performance can be explained by its higher specific surface area, which is 2.35 mg per gram, in comparison to other works, which may have something to do with the origin of the eggs and by the particle size, which is influenced by heat treatment as well as grinding and sieving methods. With that said, in the present study, the uptake of cadmium ions was 217.39 mg per gram, which is higher than other absorption of eggshells from other works. Thank you.
Thank you, Zarif. Now, I will continue the presentation with the conclusion and the recommendation part. The conclusion part is divided into three parts, which is the study goal, the evaluation, and the result. The first part is the study goal. The goal of the study was to get a thorough knowledge of the effect of the physical-chemical features of eggshell waste, as well as the effect of the experimental circumstances of the removal of cadmium ion from aqueous solutions. The second part is the evaluation part, to evaluate the physical-chemical characteristic of the adsorbent and investigate the property to performance connection. Several physical-chemical techniques were combined, such as Brownian emitter, thermogrammetric analysis, Fourier transform infrared spectroscopy, X-ray diffraction, scanning electron microscopy. The result revealed that the experimental parameters such as eggshell dosage, pH, starting ion concentration, and contact duration impact the efficiency of eggshell waste as a bioadsorbent to remove cadmium ion from aqueous solution at varying levels. The last part of the conclusion is the result part. The result shows that cadmium ion is eliminated by a chemical adsorption process represented by a pseudo-second order model that matches the experimental result and resembles the line adsorption like isotope model, including an initial metal concentration of 10 mg and an absorption dose of 0.8 gram per liter. The adsorption process is quick, reaching equilibrium at 10 minutes at pH 5. To form maximum, the adsorption capacity 217.4 mg has been recorded, which is mostly attributable to the huge specific surface area of eggshell powder used in this work. It has also been shown that nitric acid may be used to effectively remove cadmium ion from eggshell powder. Now, for the recommendation part, the current work improved the use of eggshell as an effective and low-cost material for the removal of cadmium from wastewaters. High removal efficiency, quick kinetics, and an ecology acceptable technique. That's all from this. Thank you.